Hello everyone, welcome back to IntelliSkills. In today's video, we are going to practice 36 MCQs from the chapter Natural Language Processing in Class 10. And I would recommend that you visit our NLP video, which the explanation video that I've created. You watch that, then you come here, it will be more effective for you. Okay. What is the purpose of NLP in AI? To make decisions, to help machines understand and use human language, to improve computer programming, to recognize images. Let's analyze the options. To make decisions, that is not the job of NLP specifically, that's the job of AI. To help machines understand and use human language, yes, this can be because NLP deals with decoding the human language. To improve computer programming, not exactly. And to recognize images, that's for computer vision. So it's going to be option 2, to help machines understand and use human language. You can read the explanation. Why I'm telling you, because this will be helpful if you have to answer the long questions in your exam. So this kind of wording you can follow in your exam. To answer the long questions, it will help you. Okay, let us move to question 2. What does AI typically use to find patterns and solve problems? Direct programming, random guesses, machine learning and deep learning, manual input from humans. Please pause the video and try to answer. What does AI typically use to find patterns and solve problems? Direct programming? No. Random guesses? AI doesn't do random guesses. Machine learning and deep learning? Yes, they are used to find patterns. Manual input from humans? No. So it's going to be option 3, machine learning and deep learning. You can give the explanation a reading. Why all the other options are wrong, that's also mentioned. Let us move to question 3. Which of the following is not a rule that governs languages? Syntax, lexicon, algorithm, semantics. So syntax, that is a rule, the grammatical rule. Lexicon, yes, that is also a rule, the vocabulary. Algorithm, no, that is not a rule for NLP specifically. Semantics, yeah, that's the meaning, so that is there. It's going to be option number 3, algorithm. Okay, let's see the explanation. Question 4. What is an example of an incorrect syntax? John eats an apple, eats John an apple, John apple eats, and apple John eats. Okay, for this question, first you need to know what's the correct syntax. The correct syntax is subject plus verb and plus object. Okay, so here we have the subject John plus the verb that is eats and plus the object that is an apple. So here it follows the correct syntax. So this is correct. John eats an apple, eats John an apple. Here the total order is only wrong. It's like verb plus subject plus object. Okay, verb plus subject plus object, which is wrong. So this can be an option. John apple eats. John apple eats can also be the option. An apple John eats. An apple John eats is, you cannot say that it is totally wrong, because in poems, you have this, that an apple John eats is very poisonous. So to show the possession of an apple by John, it is used in poems, so you cannot tell that it is entirely incorrect. You have these 2 options which can be incorrect. Now out of these 2 options, what to select? Eats John an apple, which is verb plus subject plus object, or this one, which is subject plus object plus verb. Option 2 is more more appropriate than option 3. That is why you can select option 2, because it is much closer to the actual incorrect syntax. If you see option 3, it just feels like the order might have been rearranged, but if you see option 2, it actually feels incorrect. So option 3 is also incorrect, but option 2 is just more closer to the incorrect syntax. You can read the explanation for further clarity. Next you have question 5. What do personal assistant applications like Siri, Cortana and Alexa primarily use to understand human language? Option 1, image recognition, NLP, data analysis, machine learning algorithms. So here you can see it talks about Siri, Cortana and Alexa, which is all the voice assistants which primarily use NLP only. So image recognition, no. Why would they need NLP? Yes, they need it. Why? Because they need to understand our human language. For that they need NLP, and they also need to give a human language like reply. For that also they need NLP. Data analysis, no. Machine learning algorithms, no. Like they are used, obviously data analysis and machine learning algorithms, they are used, but primarily it says which is NLP, sorry. So it's going to be option 2. You can see the explanation. Next you have question 6. What does lexicon refer to in language? The set of rules for sentence structure, the collection of all sounds in a language, the complete set of words and their meanings, the understanding of word context. Talking about lexicon, lexicon is the vocabulary, as I already told you. Okay, lexicon is that vocabulary or the dictionary where all the words along with the meanings, they are present. Okay, so set of rules for sentence structure, that is syntax. The collection of all sounds in a language, no. The complete set of words and their meanings, yes, because that is what technically dictionary. So we can consider this option. The understanding of word context, no, that is semantics. So it's going to be option 3, the complete set of words and their meanings. This is the explanation. Here you can also see that sounds, it says that sounds, it talks about phonetics. Okay, now you have question 7. What does AI enable machines to do in NLP? To recognize images, to handle complex language including semantics, context and structure, to make decisions based on data, to create new languages. So to recognize images, that is not the function of NLP, it is for computer vision. To handle complex language including semantics, context and structure, yes, whatever related to interpreting human language is there, it's for NLP. So this can be the option. To make decisions based on data, this is a very indirect option because it makes decisions based on language data. So to be more specific, option 2 is still correct. To create new languages, absolutely not. The main function of NLP is to interpret human language, not to create new language. So it's going to be option 2. Here is the explanation. Now we have question 8. Which step in text processing creates a list of all unique words in the normalized corpus? Text normalization, stemming, create dictionary, create document vectors. Here it says about creating a list of all unique words in a normalized corpus. So obviously text normalization is already done because it says normalized corpus. Option 1 is definitely going to be incorrect. And even after that text normalization, it means setting the same base for all the tokens of words in the sentence. Okay, means everything should be converted to lowercase. Every other word should have the same standard or the same base. Okay. So text normalization is incorrect. Stemming is not finding unique words. Create dictionary, yes, that is creating a list of all unique words, and it can also be creating a vocabulary. That is also what we call dictionary or vocabulary. Create document vectors. For creating document vectors, you need a dictionary, which is the list of all unique words, right? So it's going to be create dictionary, which is option number 3. You can read the explanation. Next you have question 9. Which term refers to the number of documents in which a specific word appears? Word frequency, term frequency, document frequency, inverse document frequency. So talking about word frequency, there is no such term as word frequency, so this is incorrect. Term frequency, I think word frequency, it was referring to term frequency only. Term frequency means the frequency of a particular term or a token in one sentence. So That is term frequency, but it is not the number of documents in which the word occurs. Document frequency is the number of documents in which a word occurs. So it can be option 3. Inverse document frequency, it uses document frequency to add weightage or reduce the weightage, or to know what is the importance of a particular word. So it's going to be option 3, which is document frequency. Refers to the number of documents in which a word can appear. Question 10. Which NLP stage checks the meaningfulness of a sentence? Lexical analysis, syntactic analysis, semantic analysis, pragmatic analysis. So in lexical analysis, the whole sentence is broken into tokens or words, okay? That is not related to meaning. Syntactic analysis is related to checking grammar and the sentence structure, whether it follows the correct structure or not. So that is also not meaningfulness. Semantic analysis, yes, semantics deals with meaning of the sentence, so that can be the answer. Pragmatic analysis, it uses that particular sentence in real world context. So pragmatic analysis is not that meaning of the particular sentence, okay? It relates it to the real world context. So it's going to be semantic analysis. Here you can see the explanation. Okay, now question 11. Which type of chatbot follows predefined rules? Smart bot, AI bot, script bot, learning bot. So if you talk about smart bot uses AI and machine learning. So that doesn't follow predefined rules. It learns with time, right? Learns with experiences. AI bot, it is built with AI. So no. Script bot, yes, script bot follows a particular script, a predefined set of rule. It's rule based. Learning bot, no. Learning bot learns using machine learning and all, so it improves with data. So it's going to be script bot. Here you can see the explanation. Now coming to question 12. What does TF-IDF stand for? Text frequency and inverse data frequency, term frequency and inverse document frequency, text frequency and inverse document factor, term frequency and inverse data frequency. So it's going to be term frequency and inverse document frequency. This is a very direct question. Explanation. Question 13. Which NLP stage arranges words and sentences according to grammar? Lexical analysis, syntactic analysis, semantic analysis, pragmatic analysis. So I've already explained what is lexical analysis, semantic analysis, pragmatic analysis. It's going to be syntactic analysis. Why? Because it says arranges words and sentences according to grammar. Grammar is the key word here. Syntactic analysis is always related to grammar. Okay, it's going to be option 2. Here you can see the explanation. Next you have question 14. Which NLP application categorizes text into predefined categories? Text summarization, text classification, sentiment analysis and machine translation. So if you have studied advanced concepts of modeling chapter, this is going to be very easy. Predefined categories it says. So if you put something into a particular category, basically you're classifying it. So here you're categorizing the text into different categories. So that is called a text classification. Okay. Text summarization means shortening a big chunk of text, keeping the important points. That is text summarization. Classification, what I told just now. Sentiment analysis, I've already told. Sentiment analysis, it means based on a particular sentence, you detect the mood of the user, okay, or the sentiment of the user, good, bad, better, like it's used in reviews. Machine translation, you already know, this is basically translating from one language to another. So categorizing text into predefined categories is going to be text classification. Here is the explanation. Next you have question 15. Which stage of NLP uses real world knowledge to interpret meaning? Lexical analysis, syntactic analysis, semantic analysis and pragmatic analysis. So here the main keyword is real world knowledge. Real world knowledge, I've already told you, there is a sentence, you connect that sentence to real world knowledge. Okay, so that is pragmatic analysis. Here you can see the explanation. Next you have question 16. Which technique converts text into numerical vectors? Tokenization, bag of words, stemming and lemmatization. So tokenization, it means breaking the words into tokens, breaking the sentence into tokens, that is called tokenization. Not converting into numerical vectors. Bag of words, it is, yes, bag of words, there you have to create numerical vectors, which is basically the frequency of every word in a particular sentence. So this can be the option. Stemming and lemmatization, both of these options are incorrect because they are basically about reducing a word to its base dictionary form. Okay, so that is stemming and lemmatization. So it's going to be bag of words. Here you can see the explanation. Again, let me tell you, I combine stemming and lemmatization. Basically, stemming, it reduces the word form without caring about the dictionary form. Lemmatization actually reduces it to a meaningful dictionary form, and stemming can make no meaning sometimes. Okay. Question 17. Which statement best explains why stop words are removed during text pre-processing? They increase the grammatical correctness of the sentences. They reduce noise and help focus on meaningful words. They help convert text into numerical form. They improve sentence segmentation accuracy. Removing stop words. Okay, stop words are what? They are those am, is, are, which are repeated multiple times and don't carry that much of importance. Okay, so why are they removed? It says they increase the grammatical correctness of the sentence. Yes, they increase the grammatical correctness, but if we remove stop words, how does this help? They reduce noise and help focus on meaningful words. Yes, this can be, because if you remove the stop words, you get all the important words, which are the important ones to make predictions. So they reduce noise. Noise means any unnecessary information, and help focus on meaningful words. This can be the option. They help convert text into numerical form. No, basically if you use bag of words or TF-IDF, then they can help convert text into numerical vectors, but for that we don't remove stop words. This is the core meaning. They improve sentence segmentation accuracy. No. So it's going to be option 2. Okay, you can see the explanation. Question 18. Why is converting text to lowercase an important pre-processing step? It removes punctuation marks. It prevents the system from becoming case sensitive. It increases the size of the vocabulary. It improves pronunciation accuracy. So converting text to lowercase. It removes punctuation marks. It says about converting text to lowercase, not removing punctuation marks. Incorrect option. Prevents the system from becoming case sensitive. Yes, this can be correct, because if you're converting to lowercase, then everything has the same standard. So the system doesn't become case sensitive, because everything is in lowercase. Nothing, some in uppercase, some in lowercase. It's not like that. It increases the size of the vocabulary. If you convert a text to lowercase, then the words are remaining same. How does it increase or decrease the size of the vocabulary, right? It's incorrect. It improves the pronunciation accuracy. Word is remaining same. It's just being converted to lowercase. So it doesn't do anything with pronunciation. So it's going to be option 2. You can see the explanation. Now we come to question 19. Which of the following best describes sentence segmentation? Breaking sentences into words, removing unnecessary symbols, dividing the text into meaningful sentences, reducing words to their root form. So here it tells about sentence segmentation, means segmenting or segregating sentences. So breaking sentences into words, that is tokenization. You have a single sentence and you break it into words. Removing unnecessary symbols, no. Dividing text into meaningful sentences. This is the option, because suppose you have a paragraph, you divide that into different sentences. So that time you do sentence segmentation. So dividing text into meaningful sentences. Reducing words to their root form, no, that's lemmatization or stemming, whatever you call it. So you can frequently confuse between these two options, first and third. It's going to be the third option. Show explanation. Then you have question 20. What is bag of words? Why is bag of words considered a simple technique? It captures meaning deeply. It captures the sentence meaning deeply. It ignores word order and grammar. It understands context automatically. It removes stop words automatically. So bag of words, it captures the sentence meaning deeply. No, it does not actually. It's the work of TF-IDF. TF-IDF does it better than back of words. It ignores word order and grammar. Yes, because you see in TF-IDF we actually get what is the weightage or importance of one particular word using the inverse document frequency, but here in bag of words you just get the frequency of every word in a sentence. So it's very simple and it ignores word order and grammar. It understands context automatically, no. Removes stop words automatically, no. That is done in TF-IDF. So it's going to be option 2. You can see the explanation. Then you have question 21. Which situation best shows the importance of semantic analysis? Checking spelling mistakes in a sentence, identifying whether a sentence makes logical sense, counting the number of words, converting text to lowercase. So importance of semantic analysis. Semantic analysis, what do you mean by that? Semantic means meaning. So it deals with the literal meaning of the sentence. Okay. Pragmatic analysis is real world meaning. Semantic means literal meaning. Checking spelling mistakes in a sentence, no. Identifying whether a sentence makes logical sense, yes, because if a sentence makes logical sense, that means it has a good meaning. The meaning is meaninging. So this can be the option. Counting the number of words, no. Converting text to lowercase, that is normalization. So it's going to be option 2. Question 22. Which stage of NLP helps understand pronouns like it or they based on previous sentences? Lexical analysis, syntactic analysis, discourse integration, pragmatic analysis. So I've already explained this. It's going to be discourse integration. Why? Because discourse integration, it goes back to the previous sentences. It checks that what is the particular, like it means dog here, they means friends here. So it establishes relationships with the previous sentences. That is discourse integration. Here is the explanation. Question 23. Why is TF-IDF considered better than simple word frequency? It removes all the common words. It highlights words important to a document. It increases vocabulary size. It preserves word order. So TF-IDF, it removes all the common words. Yes, that can be. Highlights words important to the document. Yes, that can also be. Increases vocabulary size, no. Preserves word order. Yes, it preserves word order, but most importantly, see, it removes all the common words. This can also be done in text pre-processing where we are removing the stop words. So TF-IDF's main significance is that it highlights the important words to a document. I am saying this so many times because here student can confuse. A question can come, what is the importance of, why is TF-IDF considered better than simple word frequency? This question can also come. So you have to write the main feature, that is in TF-IDF you have inverse document frequency, which tells you which words appear more, which words appear less. The words that appear less, they're more important. So you highlight the most important words to a document. Option 2. In TF-IDF, we don't remove all the common words, but we basically give them low importance, but we don't remove them, okay? You can see the explanation. Question 24. Which pre-processing step helps convert jumped, jumping and jumps to a common base form quickly? Lemmatization, tokenization, stemming and stop word removal. Lemmatization, this converts word to a base form. But does it do it quickly? Quickly is mentioned here. Lemmatization is a very slow process. Tokenization, no. Stemming, yes, this is the one because this converts word to the base form and very quickly as well. Okay. Stop word removal, no. So it's going to be stemming. You can read the explanation. Then you have 25. Why is lemmatization? Oh my god. Why is lemmatization preferred over stemming in machine translation? It is faster. It produces shorter words. It gives meaningful dictionary words. It ignores word context. So why is lemmatization preferred over stemming? That means it is asking what is the significance of lemmatization. It is faster. No, stemming is faster. Produces shorter words. The goal is not to produce shorter words, so no. It's to produce the dictionary form. It gives meaningful dictionary words. Yes, this is correct because it does give meaningful dictionary words, but it's a slower process. It ignores word context. No, it considers word context. That is why only it's able to give meaningful dictionary words, right? So it's going to be option 3. 26. Which NLP application is most useful for analyzing customer reviews on social media? Machine translation, sentiment analysis, text summarization, tokenization. So customer reviews, for analyzing customer reviews, that means you need to know what is the customer trying to say. Is it a bad review, good review, neutral review, worst review, very good review? So machine translation does not help there. What will you do translating from one language to another? So sentiment analysis, yes, this is the one because here you get to know the sentiment of the user. Text summarization, no. Tokenization, no. So it's going to be sentiment analysis. Then you have question 27. Which component of TF-IDF decreases the importance of words appearing in many documents? Term frequency, inverse document frequency, tokenization, normalization. So here it says it decreases the importance of words. Which one? See, tokenization, normalization, these are not components of TF-IDF only. So term frequency, it just gives the frequency of every term. How does this help in importance of words? It's the inverse document frequency that helps us. So it's going to be option 2. Here you can see the explanation. Question 28. Which chatbot characteristic best differentiates a smart bot from a script bot? Uses predefined menus, can learn from interactions, works only online, responds instantly. So smart bot from a script bot. Smart bot is smart, uses AI. Script bot is on predefined rules. So uses predefined menus. That is for script bot. Here it says a smart bot from a script bot. So you have to look for characteristics of a smart bot. Can learn from interactions. Yes, it is this one. Works only online. Not necessary. Responds instantly. Not necessary. So it's going to be option 2. Can learn from interactions. Next you have question 29. Which pre-processing step reduces thank you in caps to thank you in lowercase and thank you just read it, to the same font? Tokenization, case normalization, stop word removal, stemming. It says these 3 forms of thank you reduce to the same form. So reduce to the same form. Now many students will think reduce to the same form, that means reduce to the base form, that means stemming. No, reduce to the same form. Here what will you reduce? Thank you is already in its base form. Here what you can do is you can reduce them to their all lowercase you can do. So what you can do is case normalization. Case means uppercase, lowercase. So this is going to be option 2. Here is the explanation. Next question 30. Which NLP task is mainly used to automatically generate captions for videos? Text classification, speech recognition, keyword extraction, stemming. So to generate captions for videos, that means it's detecting what I'm saying. So it's detecting my speech from the video and then it is converting it to text. So it is recognizing my speech recognition. Other options are wrong because text classification, no. That's for spam email, okay. There you use text classification. You classify text into spam or not spam. Okay, stemming is not a NLP task only. It's a pre-processing step in NLP. The keyword extraction, no. So it's going to be that one, speech recognition. Here is the explanation. Then you have question 31. Which NLP concept helps classify emails as spam or not spam? Just now I told. Text classification, semantic analysis, lemmatization, tokenization. So right now only I told it's going to be text classification. Here is the explanation. Question 32. Which NLP stage uses word knowledge to interpret sentences like hang on, I'll be back? So semantic analysis, syntactic analysis, pragmatic analysis, lexical analysis. So here it says about use interpreting sentences using real world knowledge. Whenever there is real world knowledge, it's going to be pragmatic analysis. Here, hang on, I'll be back, it can mean, in real world knowledge, it means that, okay, I'm cutting the call, or I'm hanging up and I'll be right back, or hang on, wait here, I'll be right back. So it's going to be pragmatic analysis. Here you can see the explanation. Then question 33, which toolkit is most commonly used in Python for learning NLP concepts? NumPy, NLTK, Matplotlib, TensorFlow. So it's going to be NLTK. You can see the other options why they're incorrect. See, NumPy, it's used for numerical operations. Matplotlib, it's used to plot the graphs, okay? And TensorFlow, it's a deep learning concept, okay? So it's going to be NLTK. Here you get last question 34. Why are numbers sometimes removed during text pre-processing? They reduce processing speed, they always have no meaning, they may not contribute to text meaning, they break sentence structure. They reduce processing speed. Text pre-processing actually, removing numbers can actually increase the speed, because the less number of things you have, the more efficient and speedy will be the task, right? Sometimes, numbers always don't have meaning. That is wrong. Numbers can have meaning, because what if you have dates, 25th Jan, okay, or what if you have someone's phone number? So that time they have meaning, right? They may not contribute to text meaning. This can be the option. They break sentence structure. Numbers, they do not break grammar. Okay, they may not contribute to text meaning is the correct answer, because, okay, we have got a gold certificate because you have answered 34 out of 34, 100%. Let's close this for now. So they may not contribute to text meaning. If you have a sentence that is, I like this movie 100 times, and you remove 100, I like this movie, it's still making sense. So 100 times it does not contribute to the text meaning. So that's what I'm trying to say. Text pre-processing actually, removing numbers can actually increase the speed, because the less number of things you have, the more efficient and speedy will be the task, right? And if you see the explanation, this is the one. And that is it for this video. We have completed 34 MCQs. Next video will be assertion reason, and I'll meet you in the next video. Till then, keep learning, keep practicing, and keep exploring. Thank you, and bye-bye.